Welcome to Canerica's podcast, The Digital Shift. Today, we're embarking on a deep dive into a transformative area that's really reshaping industries globally. We're talking about the incredible power of AI and predictive maintenance. Our mission? Well, it's to unpack the most critical insights from the content we've explored, giving you a concise but, comprehensive understanding of how artificial intelligence is truly revolutionizing how we maintain vital equipment and infrastructure. And the core problem AI and predictive maintenance tackles is just immense. Think about the staggering costs, the massive inefficiencies of, well, the old ways of doing maintenance. Get this. Factory shutdowns, so surprise repairs. They can cost global manufacturers up to a mind-boggling $1.4 trillion every single year. Yet for way too long, many industries have simply fixed machines after they break. It's basically waiting for a disaster, right? But AI and predictive maintenance completely flips that script. One analysis shows it can cut maintenance downtime by 30% to 50%, and not just that, it can even increase machine life by 20% to 40%. This isn't just about fixing things anymore. It's about fundamentally optimizing entire operational life cycles.
And that's really the heart of it. Predictive maintenance, it's not just another buzzword. It's a profound shift. We're talking about a proactive strategy, continuously monitoring asset conditions during normal operations. The goal is to anticipate and minimize failures before they even occur, leveraging really advanced data analysis. It's a complete departure from the old methods. Think about reactive maintenance, sometimes called, kind of grimly, run to failure. That's where you just wait for a breakdown. It leads to unexpected downtime, usually at the worst possible time, and incredibly high emergency costs. Just chaos, really.
Right, the scramble to fix things after they've already gone wrong.
Exactly. Then you have preventive maintenance. That's scheduled regularly, sure, but often regardless of the equipment's actual condition. And while it might reduce some unexpected failures, it frequently means unnecessary work, replacing parts too early, wasting labor.
So you might be fixing things that aren't even broken yet.
Precisely. And we also had things like time-based or even skill-based maintenance, but they often lacked flexibility or could be skewed by, human bias. So what we're seeing here, it's not just a small step up, it's a fundamental paradigm shift in how industries manage their assets. We're moving from that costly reactive firefighting to intelligent, informed foresight, optimizing every single moment.
That really clarifies the shift from fixing problems to actively preventing them. But I think for many listening, the big question is, how? How does AI actually pull this off? What are the specific technologies, the gears grinding behind the scenes that make this kind of prediction a reality?
Yeah, it's a fascinating convergence, actually. A stack of powerful technologies working together. The foundation really is data gathering and processing. We're talking about a constant stream of real-time data. Think sensors on equipment, often connected through the Internet of Things, or IoT.
So IoT is like the machine's nervous system.
That's a great way to put it. These sensors are constantly feeding back the pulse of the machinery, temperature, vibration, pressure, you name it. It creates this incredibly rich, real-time data flow. Then AI algorithms step in to process these huge volumes, identifying critical patterns, including those really subtle deviations that might signal an impending issue. Anomaly detection is key here.
Okay, so IoT provides the signals. What's the brain interpreting all that complex information?
That would definitely be the machine learning algorithms. They're absolutely crucial. They analyze both historical records, what happened before, and that live real-time data to predict failures. And what's really cool is how different types of machine learning play different roles.
Oh, interesting. Can you break that down a bit?
Sure. So supervised learning is kind of like a mechanic learning from years of repair logs. It uses labeled data knowing what past failures look like to predict future status.
Learning from known examples. Got it.
Exactly. But then you have unsupervised learning. This is more like an investigator finding hidden clues. It spots unusual patterns or anomalies in data that hasn't been labeled, things maybe no one even knew to look for. Super useful for anomaly detection.
Finding the unknown unknowns.
Precisely. And finally, there's reinforcement learning. Think of this as the system learning by doing. It tries different maintenance schedules, sees what works best to minimize downtime or extend life, and optimizes itself over time, like constantly improving its strategy.
That's a fantastic breakdown. And sometimes we hear about neural networks and deep learning too. Where do they fit in?
They're essentially the advanced pattern recognition specialists within the machine learning family, especially deep learning. They're incredibly good with really complex, high-dimensional data like intricate vibration signatures or acoustic data. They can detect those super subtle anomalies, the tiny signals that often precede a major failure.
Okay, so they handle the really complex patterns.
Right. And supporting all this analysis, given the sheer amount of data coming from IoT, you absolutely need big data analytics. We're talking about powerful frameworks, things like Apache Hadoop and Spark. They provide the muscle to process these massive data sets quickly and efficiently.
So we have the sensors, the various learning algorithms, the deep pattern finders, and the big data processing power. What about the human side? How do people interact with these systems?
Good question. That's where natural language processing, or NLP, often comes into play. It acts as a bridge, a human interface. NLP allows the system to understand human language. Think about maintenance reports, technicians' notes, even voice commands. It can extract information from text or allow for easier interaction.
Makes the tech more accessible.
Exactly. And ultimately, all these pieces working together, IoT, ML, big data, NLP, enable that real-time monitoring and predictive analytics.
Yeah.
It means continuously analyzing data, detecting anomalies almost instantly, and predicting future behavior accurately enough to schedule proactive maintenance just when it's needed. And what's fascinating is that this isn't just theory anymore. It's actively detecting patterns humans might have missed entirely, leading to incredibly accurate and timely predictions.
Okay, the tech stack is impressive, truly, but let's shift gears. For a business leader listening, the crucial next step is implementation. How do you actually do this? It's clearly not just flipping a switch, right? It sounds like a strategic journey.
It absolutely is a journey, and it starts by looking inward. Step one is evaluating your current maintenance methods.
Yeah.
You have to ask, are we mostly reactive, just fighting fires? Do we have preventive schedules? Are they effective? Are we sitting on piles of historical data we don't use?
Understanding the starting point.
Precisely. Review your existing practices, pinpoint the weaknesses. Analyze those old maintenance logs. Where are the failure patterns? What are the real costs, including lost productivity? This helps identify where AI can deliver the most significant improvements.
Yeah, it makes sense. You need to know the pain points first. What comes after that assessment?
The second step is recognizing your critical assets. You can't, or maybe shouldn't, try to monitor everything at once, especially at the start. Create a comprehensive inventory. Then prioritize. Which machines or systems are absolutely vital to your operations? Which ones would cause the biggest headache, highest costs, frequent failures, longest downtimes if they went down?
Focus the effort where it matters most.
Just exactly. Focus where the impact will be greatest. Then, step 3 is choosing the appropriate AI technologies. Based on those critical assets and your specific goals, you research and select the right AI tools. Maybe it's a specific machine learning model. Maybe deep learning is needed for complex signals. You also have to consider practical things. Compatibility with your existing IT infrastructure, scalability for the future, and of course, the budget implications.
So matching the tech to the specific problem and context. Okay, assessment done, critical assets identified, tech chosen. Now it's data time.
Now it's absolutely data time. Step 4, collecting and integrating data. This is fundamental. Identify all the data you need, sensor readings, operational parameters, maintenance history, maybe even external data like weather, if relevant. You might need to install new sensors for real-time measurements. And critically, you need a way to bring it all together, a centralized storage system, maybe a data lake, ensuring the data is consistent, clean, and accessible. Garbage in, garbage out, right?
The quality of the data is paramount.
Absolutely. Then comes step 5, model development and training. This is where the AI really takes shape. You cleanse and pre-process that raw data. This is often a big part of the job, dealing with noise, missing values. Then you build your predictive models using the algorithms you chose, classification, regression, anomaly detection. You train these models using your historical and real-time data, and then rigorously test and evaluate their performance. How accurate are they? How reliable? You tune and optimize them.
And you wouldn't just deploy a brand new model across the whole operation immediately, I assume?
Definitely not. That leads to step 6. Testing in real-world conditions before full rollout. Start small. Conduct pilot tests on a select group of assets. Closely monitor the system. Evaluate the actual results. Did it predict accurately? Did downtime decrease? Did you save costs?
Prove the concept on a smaller scale.
Exactly. Get those tangible results. Build confidence. Learn from the pilot. Then you can strategically scale up the system across more assets. And crucially, this isn't a one-and-done thing. It's a continuous process. Monitor, refine, retrain the models as new data comes in, as conditions change. It's a living system.
A continuous improvement cycle.
That's right. And connecting this to the real world, Many organizations are already seeing huge benefits by following these kinds of steps. And, this is exactly where we at Canerica often step in. We recently worked with a fleet management company facing some really tough challenges. Frequent vehicle breakdowns, maintenance costs were spiraling, and their approach was purely reactive, just waiting for trucks to fail.
A classic scenario,
Yeah,
unfortunately.
it really is. Their old way meant unplanned downtime, higher repair bills, and just overall poor operational efficiency. They urgently needed to forecast maintenance needs, optimize their schedules, and stop those unexpected failures. So what we did at Kinerico was implement a tailored AI-based predictive maintenance system. We leveraged complex analytics, real-time vehicle monitoring, and advanced machine learning algorithms. The result? They were able to save significant time on repairs and dramatically cut those associated costs. It's a great example of AI-driven PDM in action, and it really highlights the kind of impactful solutions we focus on providing. We combine that historical data with live, real-time information to make those precise predictions. At Canerica, we're dedicated to helping organizations automate monitoring and analysis, optimize maintenance, and ultimately reduce costs.
That case study really drives home the practical value. So we've talked about the how and the implementation journey, but for me, where it gets really interesting is seeing the breadth of applications. Let's dig into some more specific examples across different sectors. It shows just how versatile this AI approach is. In manufacturing, for instance, you mentioned Siemens monitoring industrial machines. They predict breakdowns slash downtime. General Motors, too, uses sensor data to catch equipment failures early. That lets them optimize maintenance and boost production efficiency. Big impact there.
Huge impact. And in the energy industry, it's transformative. Duke Energy uses AI to predict failures in power plants. Think turbines, generators. This helps avert incredibly costly blackouts. EON does something similar with wind turbines, using AI and machine learning on sensor data to schedule maintenance proactively, extending the turbine's lifespan and making renewable energy more reliable.
That's critical for stability. Okay, what about moving goods and people, transport and logistics?
Oh, absolutely massive potential there. UPS, for example, predicts servicing needs for its huge fleet of trucks by analyzing sensor data. This ensures timely repairs, fewer breakdowns on the road, and reduced delivery delays. Keeps the packages flowing.
And in aviation, safety must be paramount.
Definitely. Delta Airlines uses AI software to monitor aircraft parts in real time. This helps reduce unscheduled maintenance, which is not only costly but disruptive. It enhances operational efficiency and, most importantly, safety.
Makes sense. Now, the oil and gas industry, high stakes, remote locations.
Exactly. The risks are immense. BP uses AI to predict equipment failures on offshore drilling rigs. Minimizing downtime there is crucial, but so is preventing environmental incidents. AI helps on both fronts. ExxonMobil applies AI to monitor vast pipeline networks, detecting tiny anomalies that could indicate leaks or potential problems, ensuring safer operation over thousands of miles.
And finally, an industry many of us interact with daily, automotive. How's AI playing out there in terms of maintenance?
Well, Tesla is a prime example. They integrate AI directly into their cars to monitor key systems. The car can actually tell the owner about potential issues before they become major problems, reducing unexpected breakdowns.
Predictive maintenance for the consumer.
Right. And behind the scenes, in the factories, Toyota uses sophisticated data analytics to predict failures in their manufacturing machinery. This prevents production line stoppages and helps maintain their famous quality standards. These examples really show it's not just a niche technology, it's becoming fundamental across the board.
It really does. Seeing it applied in so many different ways is powerful. So, stepping back again, let's summarize. Beyond these specifics, what are the big, overarching benefits that make AI and predictive maintenance so compelling for almost any industry with physical assets?
I think the number one benefit almost always is cost savings. It's dramatic. By predicting failures, you drastically cut down on those expensive unplanned breakdowns and the high cost of emergency repairs. Planned maintenance is always cheaper.
Moving from emergency budgets to planned budgets.
Exactly. Second, you get longer equipment life. Because you're doing maintenance based on actual condition, not just a generic schedule, you extend the useful lifespan of your machinery. You're not over-maintaining or under-maintaining.
Getting more value from your assets.
Precisely. Third, there's significantly decreased idle time. Predicting those sudden breakdowns means operations keep running smoothly. Less downtime equals more productivity, and that saves enormous costs.
Keeping the wheels turning, literally sometimes.
Right. Fourth is enhanced efficiency. When you can optimally plan necessary repairs, you use your labor and resources much more effectively. Everything just runs smoother. Fifth, there's improved accuracy. AI models, when built correctly, provide much more reliable predictions than gut feelings or simple time-based schedules. This allows for more dependable maintenance decisions.
Data-driven decisions.
Absolutely. And finally, a key advantage is scalability. Once you develop and validate these AI-driven solutions, you can often apply them consistently across many different assets, even across multiple sites or globally. It brings a unified, intelligent approach.
Okay, the benefits are clear. Significant cost savings, longer life, less downtime, better efficiency. It's powerful stuff. So, what does this mean looking ahead? The integration of AI and predictive maintenance is clearly still evolving. What are some of the key future trends we should be keeping an eye on? Where is this heading?
It's definitely an exciting space.
Hmm.
One major trend is the expansion into smart cities and much deeper IoT integration. We'll see AI-powered predictive maintenance move beyond factories and fleets to monitor public infrastructure, think bridges, water mains, public transport systems, making cities safer and more efficient. And the sheer proliferation of IoT devices will just generate richer, more granular data, leading to even more accurate models.
Oh, so smarter cities powered by predictive insights.
Exactly. And the AI itself will keep getting better. We'll see continuously better machine learning and data analytics. More sophisticated algorithms will emerge, capable of handling even larger, more complex data sets. Think multimodal data, making even more precise predictions, deeper insights into equipment health.
The models themselves will evolve.
Definitely. Another key trend is real-time computing at the edge. Instead of sending all the raw sensor data to the cloud for analysis, more processing will happen directly on or near the equipment itself.
Why is that important?
It minimizes latency. You get faster analysis, faster decision-making, which is crucial for systems where a split second matters. It improves efficiency and responsiveness.
Makes sense for immediate action. And you hear a lot about digital twins these days. How do they fit into the future of PDM?
Ah, yes. Digital twins are rapidly becoming a mainstream tool. These are essentially dynamic virtual replicas of physical assets. You can use them to run simulations, test what-if scenarios, predict how an asset will behave under different conditions, all without impacting the real thing. It dramatically improves prediction accuracy and helps manage the entire asset lifecycle.
Like a virtual testing ground?
Exactly. Now, with all these connected devices and AI systems, cybersecurity becomes absolutely critical. As reliance grows, protecting the data and the systems themselves is paramount. We're talking robust data security encryption, secure communication protocols, and ensuring system integrity through things like regular audits and access controls. Trust is essential.
A really crucial point. You need to trust the data and the predictions. What about newer technologies like blockchain? Any role there?
It's an interesting prospect. Blockchain technology is gaining momentum, at least in discussions. The potential is there to revolutionize data management for maintenance. Imagine tamper-proof records for all service activities, all sensor readings. It could increase transparency and trust, maybe even enable new service models through decentralized systems.
So, immutable records for maintenance history.
That's the idea. You could add another layer of resilience and security. Of course, there are still hurdles like scalability and integration, but it's definitely a trend to watch.
It certainly points towards a future of more interconnected, intelligent, and hopefully trustworthy systems. How can organizations best prepare themselves now to leverage these future advancements? It sounds like constant evolution.
It really is about continuous evolution. The key is staying adaptable and maintaining a forward-thinking mindset. Organizations need to foster a culture of data literacy and be willing to experiment and iterate. And, importantly, build strong foundations now. Good data governance, robust IT infrastructure, clear strategic goals for maintenance. That prepares them to adopt new technologies as they mature. This is something we at Canerica are deeply focused on, helping organizations not just implement current solutions, but also prepare for what's next. We provide AI-driven predictive maintenance solutions designed to automate monitoring, optimize maintenance, reduce costs, and ensure our partners are truly ready for the operational landscape of tomorrow.
We have certainly covered a lot of ground today. We went from the fundamental problems and costs of traditional maintenance through the intricate AI technologies making prediction possible. We looked at real-world applications across so many sectors, the tangible benefits businesses are seeing, and now these exciting future trends. I think the core takeaway is incredibly clear. AI and predictive maintenance isn't just a fancy way to avoid breakdowns. It's about fundamentally transforming operational efficiency, significantly extending asset life, and unlocking enormous value across industries. It's a strategic imperative now. So here's your challenge for deeper exploration after this deep dive. Take a moment and consider an asset in your own daily life. Maybe it's your car, a key appliance in your home, perhaps even public infrastructure you rely on, like a bridge or the local train system. How might AI driven predictive maintenance change your experience with that asset in the future? What new possibilities does this open up, not just for businesses seeking efficiency, but for how you personally live and interact with the technology and infrastructure all around us? Something to think about. Thank you so much for joining us on this deep dive into AI in predictive maintenance on Canerica's The Digital Shift. We really hope this conversation has provided valuable insights and sparked your curiosity for the digital future that's unfolding right now.